Welcome back to Arcade. I am Super Tommy, and this is a series or a set of videos going over creating a Pac-Man Ghost AI, or all four Pac-Man Ghost AIs and their auxiliary scatter AI. Now, in the last video, we abstracted our Ghost class movement logic into a scatter AI state using the state pattern. So now what we can do is simply, let's go to our Ghost AI, is simply pass in whatever AI we want to use. In this case, scatter AI is what we're doing right now. And then we will call the state to pick a direction, and then whatever direction this AI picks, we will use. So we've delegated that behavior to our scatter AI class, or any iGhost AI, or any class that implements the iGhost AI interface, passed in when we create the ghost here in our game class right here. So now what we're going to do is build on top of all of this and create Blinky's AI when he's chasing Pac-Man. So this is going to be the generic chase AI, let's want to call it at least. And we're going to do this for Blinky. So Blinky is the red ghost. And so this article here, as we like at the top, goes into the entire Pac-Man AI and game design, or at least AI design of the game. We're not going to handle that in this video. We're only interested in the Ghost AI. And so here we go. No, this is discussing how it works, which we talked about in a previous video. So individual ghost personalities. This is scatter, like we talked about. So we did that in the last video. Red Ghost. This article does not name Blinky by name, but Blinky is the red ghost. And so what Blinky does is it picks a target and then it goes there. And so the target Blinky picks is actually Pac-Man. So wherever Pac-Man is, that is the target. So let's implement that AI right now. So we're going to make a new class in our new Ghost AI folder, Chase AI. Well, Chase Hero AI. And so hero is going to be Pac-Man. Export default class Chase Hero AI. And so we want to implement iGhost AI. So this is, we talked about this in the previous video, but just to recap, we're programming against an interface and not a implementation, so that in our new Ghost, we can give it any AI behavior that implements the iGhost AI interface. So this is programming against an interface, not an implementation, so that we can leave this as taking in any iGhost AI and not have to go back here and update it. Take a chase AI, a flank AI, an intercept AI, a scatter AI, or any number of AIs you can create as long as you adhere to this interface. So that this code is simpler and we can make any number of concrete implementations and give it to our Ghost class. Okay, so this is our chase hero. And let's just go to our interface here. We see there is these three things that we must have: a speed, a target position, and a pick direction. So the target position we really only need so that we can draw that X on screen that we showed you in the first video. So we will probably do that in this video too, so that we can see where the target is supposed to be. So pick direction, just to get our errors to go away, or these squigglies. Let's just do a very generic implementation of all the required properties and methods. So x0, y0. Okay, so squigglies are gone. So this is the most bare bone way we can implement a concrete iGhost AI implementation. So for the chase hero AI, Blinky will chase Pac-Man. So wherever Pac-Man is. So Blinky needs to know where Pac-Man is. So to do that, we need to pass in the hero to our constructor when we create this chase hero AI. So constructor, say hero, and we do have a hero class. Yep. So hero is a concrete implementation. We don't actually have an interface. We didn't make one. Maybe we should have, but for now, we'll just leave this as is. So it has to take specifically the hero class and not any hero that happens to implement a hero interface. So this is less flexible than using an interface, as you You can see that now. Okay, so we're going to chase Pac-Man, so we know we need that. And we also know when we move that we can't move into a board, into a tile space, so like one of these walls, right? So we need the tile map, or the lay a tile layer that represents the board, so we can check that. Let's save these or store these as class properties. Okay, dot dynamic tile layer. Okay, so this dot hero is hero. This dot board is board. All right, so now we got to pick a direction. Now let's look at how we did in scatter AI. So now because we're using the state pattern, our classes are now much smaller and self-contained. Instead of having to look at everything inside our ghost class to like determine what to do, what we have, the code we have to implement is very simply just this small amount of code. So it's going to be simple, similar to this. So let's see, we need a target, right? So tx, so we actually know, in our case, it's going to be, it's going to be this dot hero dot body as physics.arcade.body. So we're doing this because this could be either static or dynamic, but we know it's going to be dynamic, so we can just cast it and then get better IntelliSense. So body.position.x and body.position.y. Okay, good. So that's the position. So tx, and we went over this in the last video, but go over this again. We're going to do object destructuring. So what this does is it's going to take the x value out of target position and put it into this tx variable that we're making. This is just the syntax for object destructuring. You can check out our previous video for more information, or just look up object destructuring in modern JavaScript or TypeScript. Okay, so now we have target, the txty, that's the target, which is wherever Pac-Man happens to be. And then we want to go in that direction. So we know we don't want to go backwards, right? So let's see, backwards direction is get opposite direction. Yes, so it's going to auto import. Did it? Yes. So this is a helper function that we've already written that, given a direction, returns its opposite direction. And here, get opposite direction. So we can only get it by, so the ghost itself knows which direction it's going. So we also need to pass in the ghost that this AI is using. Private ghost. So this is a ghost interface. So our hero is not against the interface, but our ghost is against the interface. So we can pass in any type of ghost. It could be like a giant ghost that walks a little bit differently. If you wanted to make one, and you can pass it in here and use this chase hero AI. While the hero, if you made like a different hero, you couldn't do that here because it expects a hero specifically, or that hero type specifically. Okay, this dot ghost dot current direction. So this gives us our backwards direction. And then now we want the possible directions that we can go. So get ordered directions, which is another helper function that gives us the directions in the correct order. So in Pac-Man, it picks top, left, down, and then right in that order if the decision is to choose between those. Like, let's say you can go left or top, it's going to choose top. And this helper function gets it to us in this order and has a little filter function we can pass in that filters direction that we do not want. So in this case, we know we cannot go backwards. So we only want the directions that is not our backwards direction. So if we're going right, it's going to be up, left, and down. Cool. So for I, so actually let's try a for of. So this is another for loop type. So there's for of, so constr of directions. And so this is a for of loop. I believe this is in modern JavaScript and TypeScript both. But you can also use a classic for loop if you wanted to. But this just saves us having to create our counter variable I. Okay, so let's see. So we want best direction. So now if you followed us from the last video, you'll already see that this is looks exactly like the scatter AI, and you'd be right. But let's just write this out for now. Okay. So what we want to do is pick the best direction to go to, which is going to be the shortest distance to target. So we're going to test the up direction, which is going to be one tile up from wherever Blinky is. But in this case, it can't be. So in this specific case, it's here, and that's it, because it can't go up, can't go down, and it can't go left, because that's going backwards. It's going to test the distance between this point and Pac-Man. So if it was somewhere else, let's say, and it could go up, it would be the right position in Pac-Man and the top position in Pac-Man. So if it could go up, top would win. In this case, it can only go right, where this picture is. So we're going to go through each of the directions and find the direction that it can go in that is the shortest from the target. Okay. So that means, so distance, I just get the distance. No, we need the position of the direction that it's going to go. And so we have position in direction, which is another helper function that we've created right here, which given where you are now, like your XY, and the direction you will want to go to, let's say up, it's going to give you that position based on your current position. So if you're going up and your XY is this, it's going to be no change in X, and then Y will be minus tile size, which is 32. So position in direction, so we need our current direction, or our current position. More object destructuring. If you got confused by this syntax, it may just be better not to use it. But if you are, but you can see that you can save a lot of work here. Well, not a lot of work, a lot of typing at least. When it transpiles the code, it'll do it like you could have written it out anyway. But it's more, can't think of the word right now, but it's less code for us to have to write. Okay, directions. So we're going to loop through the possible directions in the proper order, and then find the smallest distance to the target. So phaser dot math dot distance dot between will give us the distance between two XY positions. So tx, ty, and then position x and position y, constant distance. So in this case, if best direction is direction none, that means we've not set anything yet. We can, before we continue, just set best direction to direction and then best direction distance to this first calculated distance. Because since we haven't set it, the first one we get is going to be the best one. In the case that we already have a best direction, now we did this in scatter AI if you remember, we will actually do some checking. So if distance is actually less than the best direction distance, if this is the case, best direction is going to be whatever this direction is, and then best direction distance is the new distance calculated here. And so this is an algorithm to find the minimum of something. It's the same for the maximum, you just gotta change your testing. Instead of less than, be greater than. So now we don't do less than or equal to because we're getting the directions already in the right order. So only if your distance is actually better will we change it. If it's the same, we want to keep the one we already checked first because the directions are in the order that the game should pick from. Okay, so there's that. And then down here, we're going to return best direction. Okay, so that seems like the correct logic, except I just realized. So we don't actually want X and Y here. We want, like our scatter AI, the grid position, just for the most accurate. It may actually not matter, but this is more accurate because the ghost could be a little bit off or a little bit, because we're checking that it's within 3 pixels of the center of the tile to consider that a move. If that doesn't move past, then we forget a move, or we skip a move. So checking the actual grid position that should be considered the grid, where a new grid is better. And actually, in fact, now that I think of it, let's go back to our ghost class. Realistically, we should do this so that we don't have any weird cases where it is slightly off from the center of the track. I think this is right. Let's see. Yeah, our ghost should still do scatter. Okay. So now let's test out our chase AI. So I'm going to come here. So instead of this, ghost.setAI new, let's just import it manually, import chase hero AI from game, our new ghost AI, chase hero AI, back down here. So new chase hero AI, the hero is going to be this dot hero, and then ghost, and then this dot board layer. Okay, so ghost, what's the error? New ghost is not assignable to type ghost. Oh, I think I said, oh, yeah. This should be the interface, not the actual ghost implementation. This is, I don't know. This is the previous class. I was just testing it. Okay. Let's go here. Chase hero AI. It re-implemented it, re-imported it. Oh, chaser hero AI. Typos. No, what is the need? Or undefined, yes. Just trust me, it's there. Oh, okay. Parameters were not what I thought. Okay, ghost first, then hero, then board layer, comma. Okay. All right, we didn't check the board. So it's chasing Pac-Man, as you can see. So now we need to actually check in our chase hero. Let's just close this, chase hero. So we checked this for each direction. We should also check, so if this dot board, this is the board tile map, tile layer, dot get tile at world xy position x dot x position dot y. So if there is a tile there, so if there is a wall, you can move there. So it's going to come down to Pac-Man. I'm going to run, and it's going to chase. Look at that. It's good. Okay, so that is the chase AI, and you can see here that we have a lot of repeated logic between this and the scatter AI. Where's my scatter AI? Here, right? They're basically the same. So what we can do is actually create a function that has the logic for determining movement, so that the scatter AI can use this, and the chase AI can use this, and all future AI can use the same thing. So that is it for this video, which has gone on pretty long. And we're going to, in the next video, take out the common ghost moving logic into a function that we can use between all our different ghost AI implementations.